Okay, let's continue with section 3.4 and finding the derivative. All right, in example 3, find the derivative of this function. So it's going to be a little bit of a different process to do the algebra to clean it up, but we will find out a new function that will tell us the slope of the tangent line at any point. Or we could also call it the instantaneous rate of change of this curve at any point. Okay, and it has to be at any point that's a part of its domain. Notice that 0 is not allowed to be plugged in, and so that means that 0 is not allowed to be plugged into the derivative either. Okay, and we'll talk about existence of the derivative at the end of this section. So anyways, let's go ahead and write it out. F prime of x, and so I'll go ahead and write the definition each time. The limit as h goes to 0 of f of x plus h minus f of x over h. So just so that we can memorize that definition. Okay, and again, write the limit each time until the end. The limit as h goes to 0. So f of x plus h. So this is going to be 3 over input. So x plus h. Okay, so that's the function this time. Minus f of x. So f of x is just itself. Okay, divided by h. Okay, so here's where it's a little bit of a more complicated mess compared to just like the polynomial situation where we FOIL it out and distribute. So how do we simplify these fractions on top of fractions? Okay, well, we've done a little bit of practice with this. In order to clear fractions when you've got fractions inside of fractions is we multiply the numerator and the denominator by a big fancy 1 that causes all of the fractions to clear. So the common denominator of all of the fractions here are x plus h and x separately. So I'm going to multiply the numerator and the denominator by x times x plus h. Okay, and it's going to get a little bit chaotic, but there'll be some nice reducing. Okay, so on the numerator here, when we distribute onto that first part, notice that the x plus h over x plus h will cancel. And so we'll be left with this x with the 3. When we distribute onto this next part, that's minus, this time the x over x will cancel, and we're left with 3 from the numerator times the x plus h. Okay, and it might help if you like think about these as you're writing it as like each of those is over 1, so you can really see like numerators go with numerators and denominators go with denominators. Okay, so that is the clearing of the fractions from the top. On the bottom, just multiply everything next to each other. Don't distribute anything out. So I'll just write this as like hx times x plus h. Okay, so I'm not going to distribute anything else. I'm going to leave all of that alone. Okay, so a little bit of a chaotic mess there to clear those fractions, but now there should be some nice reducing. So we'll have the limit as h goes to 0. And then up here, let's see, let's distribute that. We'll have 3x and then minus 3x and minus 3h over hx times x plus h. Okay, so notice 3x and minus 3x are gone. So maybe it even seems like a little bit less work to get the h's to cancel compared to the polynomial, even though there was that weird mess with clearing fractions. But notice that on the numerator, we don't even need to really think about factoring an h out because it's just 3 times h. And so that h can cancel with that h because it's all multiplication. And that's the satisfying part where we know that the limit is going to work now because we got rid of the divide by 0 problem. Okay, because now when we use direct substitution, let's see what happens. So direct substitution for h going to 0. Excuse me. So the negative 3 is not affected. Okay, x's are not affected, but the h is now a 0. Okay, this does not cause divide by 0 because then it's just x times x down there, and we get negative 3 over x squared. And so all of that work was f prime of x. So let me just write it down again. F prime of x equals negative 3 over x squared. Okay, and that's all they wanted. If they wanted us to continue to find like the slope of a tangent line at a certain point or the equation of the tangent line, then we can proceed because this would give us the slope anywhere we want. Except at 0, of course, right? You can't plug in 0. And it totally makes sense that there's no possible tangent line touching this graph at 0 because the graph doesn't even exist at 0. We'll talk about that kind of stuff a little bit later. Okay, so that one's done. Let's try example 4 here. Okay, a little bit of an application. So the weight of a dog in pounds, X weeks after switching to a new brand of food can be approximated by the function W of X equals square root X plus 30 for 0 less than or equal to X less than or equal to 7. Okay, so yeah, just some kind of weight function, and we got 0 to 7 in weeks. Okay. So here we go. Find the rate of change. Okay, remember when it says rate of change, that's instantaneous. Okay, so rate of change, that's instant. Okay, unless they use the word average. Okay, so from now on, we're assuming that that's instantaneous. Okay, after X weeks. So we're not plugging in anything. We're literally just finding the derivative. Okay, so here we go. I'll write it as W prime of X. Okay, so whatever the function's called, you could always just do that W prime or F prime or G prime, whatever the function is, it's W prime of X. Okay, so I'll write the definition again. It's the limit as H goes to 0 of, and this time it's W, so let's write it as W of X plus H minus W of X over H. Okay, so just adjusting the notation slightly because this function has a different name. Okay, let's go ahead and plug stuff in now. The limit as H goes to 0 of, okay, so W of X plus H. The function says square root of input. So square root of input, and then it has plus 30, okay? So that's the first part. Then minus W of X, and I use extra big parentheses here. W of X is just the function itself. So the whole square root X plus 30, like so. All over H. Okay, let's do some cleaning. The limit as H goes to 0 of square root of X plus H. Okay, so then we have plus 30 minus square root X, and then that'll be minus 30 when we distribute that negative in there. Okay, plus 30 and minus 30 cancels, so that's pretty nice. But we do have a square root situation, which requires a different technique. So if you recall, if we have square roots involved, I believe we've done stuff like this a little bit in the past. If you try the direct substitution, you'll quickly see we have 0 divided by 0. So this is a situation where we want to rationalize the numerator. So I'll make a note of that. We want to, I'll write it over here. We want to rationalize . Okay, and it's going to cause some nice cancellation. Okay, but it's going to get a little bit crazy, so let's write this. Now remember, in order to rationalize the numerator when there's square roots involved, is you multiply the numerator and denominator by the conjugate of the numerator. So remember that the conjugate is the exact same expression, just with the opposite sign in the middle. So instead of minus, it's plus. Okay, and this is a big fancy 1. We're not changing the value of the expression. Okay, so here we go. I'll write out all the steps. Even though the simplifying happens in a very nice, predictable way, I'll go ahead and show all of the steps here. And so when we FOIL out the numerator, It might help to put those parentheses on there and then think about this. So for the x plus h, the root x plus h times root x plus h, square root times square root will cancel out, and we get just the x plus h. Okay, and then here's where it gets a little bit crazy. I guess I'll write it all, but we'll see how it'll cancel nicely. We'll have root of x plus h times root x. So I'll just write it like this. Root x times root x plus h. This part's not really necessary, but I want to show you where everything goes. Because then when we do the inner parts, then it's going to be minus root x times root x plus h. And so that whole middle stuff is going to cancel out. Okay, but that's why. That's what the conjugate magic. Okay, and then the last one is root x times root x, with one of them being minus, and so the square root is gone. And on the bottom, don't distribute this out because we're expecting, if it's in a factored form, there should be some nice canceling that happens. So don't distribute this. Go ahead and just write it all the same, like that. Okay, the conjugate magic, those two middle terms should be perfectly opposites and cancel out. And then there's also some more magic in this whole process of finding the derivative. Notice that there's this positive x in the front and this minus x in the back that also cancels out. So now we've got the limit as h goes to 0 of, and all that's left on top is an h. And then, like I said, we're expecting if we leave it factored out, there should be some nice canceling. And there is, because the h is the only thing that's left on top, so that can cancel. And so now it's just 1 up there. And on the bottom, we have the square root of x plus h plus square root x. So now that we've canceled that 0 over 0 problem, we can go ahead and try direct substitution again. Okay, so now no more limit that I need to write because I'm plugging in 0 now. So 1 divided by square root. Now 0 is being plugged in for h, so it's x plus 0 plus square root x. And yeah, no more divide by 0 problems because now it's just square root x plus square root x. And those are the exact same radical with the exact same radicand, okay, the same thing on the inside. So we can think of it as combining like terms, 2 root x. Okay, now there's a possible divide by 0 problem if we plug in 0 for x. So that's going to be a moment when the derivative does not exist. Okay, but the h, that canceled away, and plugging in h is 0, no more problems. And so yeah, we've got our w prime of x is 1 over 2 root x. So that is the derivative. Okay, kind of interesting that that plus 30 on the outside is not even involved in the derivative. So that's an interesting point. Okay, so that was most of the work for this problem, because now for part B, at what rate is the dog gaining weight after 4 weeks? Okay, that just means plug in x equals 4 to the derivative. Okay, so a lot of times on these types of problems, you'll have like part A where you actually have to find the derivative, which is where most of the work is. And then part B is when you just use part A. So we're ready to go. W prime of 4 equals 1 over 2 root 4. So yeah, the derivative, remember, it's just a function and you can plug stuff into it. So 1 over 2 times square root 4 is 2. 2 times 2, so we get 1/4. Okay, now what are the units here? Because remember, there's some kind of a rate going on. So 1/4. What does this function represent? This is the dog's weight. So since this is a positive number, think about this function. There's a positive increase, an increase in the dog's weight. So the dog's weight is increasing 1/4, a quarter of a pound per week. So 1/4 pound per week. This is the rate that the dog is gaining weight at week 4. increasing its weight at a quarter-pound per week. Okay, now if we worked out that process at week 5, it'll probably be a different rate. Okay, because this function is a square root function. So it's curving, it's changing. So the rate, the instantaneous rate, is probably different at w prime of 5 and w prime of 6 and so on. Okay, but right at 4 weeks, the dog is gaining weight at a quarter-pound a week. Okay, good stuff. Let's see. I think I'll make a separate video to pick up on example 5.